Okay, all of you able to see the PowerPoint slide, right?
Yes, sir.
Yeah, okay, good. Cool, you able to see, yeah?
Yes.
You're using your laptop or your phone?
Using phone.
Okay, so next time we recommend use to UPC because phone sometimes the resolution is not very good unless you have a big screen there. Okay, yeah. So the learning experience won't be good if you use a phone. Right. So for chapter 1, we're going to look at some property for fluid, and we're going to look at 4 things here. So we're going to look at liquid and gases, and then by the end of this module, you should know what is Newtonian fluid and non-Newtonian fluid. So these 2 concepts are very important, either when you do thermodynamics module or your next semester module. Okay. We're going to do look at unit dimension. This one basic, just refresh on units and dimension, and also some fluid properties. Okay. Right. Now these are a few steps, notes to all of you. These are the steps that we're going to use every time we come to solve a problems. Okay. So this I'll list out a few steps. So first one, when you get a question or get a statement, read the question and then try to understand it and then write the information on a paper. Means you read, for example, you read question 1, then you read through, try to understand what we're trying to ask you, and then before you answer anything, write down the important parameter that is given. For example, temperature, velocity, right? And then for this module, because we are having an online exam, so all the appendix or all the standard chart will be already given to you. So you should know where to look for all the standard value. For example, temperature, density of the water at 20 degrees C, what is the density at that particular temperature? Okay. So, and then if you are given a system, for example, a system, then you should know what is free body diagram. So you draw the free body diagram on the paper. Then after that, recall back the important formula that we're going to use, right? So write the parameter. If you can draw a free body diagram, and then write the formula, write out the general formula for that particular question or basic law. For example, if the question asks you about, you need to use the second Newton law, you write the second Newton law, F equal to ma, you get 1 mark already before you solve any question, before you solve or you go and calculate the true value of that one. So for this module, if you're able to write the correct formula in your answer, you will get some marks for it. Okay. Even though we know that you are having an online and you are online exam and you have all the notes beside you, but the important thing is that we are looking for evidence that you understand what you're trying to say in your answer. Okay, and then if there any assumption, you write assumption in your answer. Okay, and then then be careful when you substitute the value. For this module, most of the time the student they did mistakes when they substitute answer from the previous calculation, right? Sometimes they forget to carry forward the negative sign. Sometimes they forget to change the unit to unit SI, because sometimes again, for your tips, for engineering module, I like to change the unit to not a standard unit. For example, I give you a length. I always like to give in cm. For example, I ask you to calculate something in 10 cm, or sometimes I give you something in 15 mm. You need to change it into unit SI. With this, you need to change it to meter. For example, all these things. And then be careful on substitution on your answer. And then check your answer. For this module, there will be one part of the question. For example, question 1, we will have A, B, C, D. Most of the time, when it comes to the last session, I will ask you, what does that value mean? For example, you calculate velocity equal to 10 meters per second. I will ask you, what is this? Does this value will make the thing move to which direction? For example, I will ask you. So you need to explain the behavior under this value. Okay, so you need to answer this one. Okay, and then yeah, label your answer correctly lah. So this will help us to mark your answer. So these are the general rules that or suggestion that we give to student when you want to solve a question. Okay, now we start with the tutorial question. Question 1, I already mentioned all the important point there. So you can fill in the blanks if you're not able to follow later on, because I'm going to give you the PowerPoint slide anyway, right? So important is that before I change slide, before I change to a new slide pages, stop me if you're not able to understand. For example, something on the screen that you don't understand, stop me and ask me question. Okay. Now we're going to question 2 in your tutorial. We're going to ask you about the definition of fluid. What mean by fluid in the context of this module? So as an engineer, you should be able to define something that given to you. So a fluid is something that can deform continuously under a loading, and this loading is called shear stress. Okay, shear stress. So you should know what is normal stress, what is tensile stress. Okay, so let's revise what you learned in your stress analysis or other physics module. So let's say you have a cylinder. Okay, you have a few type of forces, and if the forces, the first type of forces is called tensile stress, which is pulling to both ends. So this is called tensile stress. Or maybe I give you a force. I change it to force. So if this force is perpendicular to, let's say I draw a 2D cross section. This is the area that I highlight here. So if the force is perpendicular to the area here, is called normal force. Sorry for my writing here. I'll try to write on using my mouse. Normal force. Normal because it's 90 degree. And this side also same, 90 degree. So we have a normal force. And if your force, if your force is acting like that, acting vertically, and I try to draw it in 2D. So what you look at, the force on the left will go up, the stress on the force on the right will go down. So your force will go like that. So this kind of force that parallel to the area, we call it tangential force. It is parallel to the force. And we can change the force to the stress. Okay. Now what is stress? Stress, by definition, is force divided by area. You have two kinds of force. The first kind is called normal stress. The second one is called shear stress. Both are stress, but because of the name that you that we name for it, it will be different. So if the force is perpendicular to the area, you will get normal stress. The symbol is sigma, so it will be normal. It will be normal stress here. So and it's because of the direction is pulling from both ends, you will have tensile stress. And if the force is compressing, is going in both sides, you will get compression stress. This is just a refresh. I think you learned it somewhere. Just a refresh. So we look at another diagram here where we have force that go parallel to the area. Then in this case, you will have shear stress that go parallel to the area here, given by this symbol, like a small epsilon there. Okay, so make sure you know when we talk about normal stress or normal force or tangential force or shear stress, make sure in your mind you know the direction of the force. Okay, now if you study engineering, be careful on the direction of the loading, direction of the force, right? So we're going to move on. So when we talk about float, we are dealing with shear stress. We are dealing with shear stress. So there's a first diagram. There's a diagram in your tutorial question. Under there's one diagram, same like what you see on the screen now. So when we talk about shear stress, the force is go parallel to the area of the float. So the diagram you see here on the left, A here is we're having a two plate. We have a two plate, and then we have a medium. We have something between the two horizontal plate. It can be solid or fluid. So in this case, we're going to look at fluid. What are the differences between the fluid and solid? So if you have a shear stress, for example, you have two plates, you have a top plate here and bottom plate here. Let's say your bottom plate do not move, and the top plate is applying a shear force or shear stress on the object here. It can be solid or fluid. So we know that solid will able to deform if we apply sufficient force on the top. It will deform from the gray line here to a solid line here. Okay, it will deform like that. However, if our force is less than our elastic solid, if our force apply here do not go more than the elastic region of our solid medium, it will no longer go further. And then you let go of the force, your solid will come back to its original form. However, for fluid, if you continue to apply a shear force, the fluid will continue to deform. It will continue to deform and continue to deform for fluid. This kind of behavior happen on fluid only. That's why we define our fluid as a substance that deform continuously under a shear stress. Okay, under a shear stress. So, okay, so these are a few notes that I already explained. You can read it after this. Yeah, so assumption here is that on the fluid medium here, you will see that there's no slip condition happen on the contact surface between the plate and the fluid here. Okay. Now, fluid here is not restricted to water. It can be anything that not in solid form. Okay. So I think you should be able to differentiate what is solid, what is something that moving. What is fluid? Okay, it's not restricted to water only. So in this module, it can be air, it can be other things. It can be mercury, it can be other things that you can find in your appendix A and E. Okay. Now the first formula that we're going to look at. Before that, we look at definition first. Solid or solid medium or solid body. One technical word that we always mention is modulus of rigidity or elasticity, which is given by capital E. And for fluid, we will look at viscosity, which is in the symbol of mu. So be careful when we learn about introduction to fluid mechanics. We will most of the time we will look at viscosity rather than the modulus of rigidity. So at least it helps you to understand something about the formula that you're going to use for this module. Okay, so at this moment, you should always remind yourself, solid will always depends on modulus of rigidity. Fluid will always depend on viscosity. Right, now another new names here, I highlight on the slide here at the bottom here. So sorry for those using handphone, you might not able to see very clearly. So the word is called viscous elastic. Viscous elastic here, it means that it having the behavior of both solid and fluid. Means is have some elasticity and also some behavior that act under viscosity. So example is like polymer, like plastic, and also your body tissue. Okay, so so at least some technical word that you learned, I think 10 minutes ago, is definition of fluid, and then what is viscosity? What medium depends on viscosity? What medium depends on modulus of rigidity? Okay, when we talk about fluid, it means we only consider the action under shear stress. So this is a fundamental understanding that you should always keep in mind when you try to solve question for this module. Okay. So I'm going to look at a few basic law that apply for fluid. I'm going to give you all in one go, since you can read from the screen. Okay, so the first law that we're going to look at is conservation of mass. Conservation of mass. The keyword is mass with its M. It means anything that related to M in the system will always equal to 0. Okay. The second one is the famous one, second Newton law, which you'll need it in your test and also exam. So second Newton law is about law of motion. The keyword is motion. The formula is F equal to ma. All right. Now sometimes some textbook they call this second Newton law as principle of linear momentum. But linear momentum equation come from second Newton law. So F equal to ma. So this is the equation that you always need to remember as long as you study this module or engineering module. Okay, so in the exam, if you write F equal to ma, I'll give you 1 mark in the answer. It's very easy to score for this module, right? So principle of angular momentum, there are a few equations we'll look at. The keyword is momentum. And then we'll consider the effect of thermodynamics. So we will look at 2 thermodynamic law. So we have first law and second law of thermodynamics. Okay, so for chapter 1, even up to your chapter 5, these 5 principle or law, you always see it when we try to cover a certain topic. The first thing, we'll deal with mass. What happened to the mass? What happened to the motion? What happened to the momentum? And what happened to the thermodynamics or energy? So just to memorize, what is thermodynamic deal? It deal with energy. Okay, mass, motion, momentum, and energy. Energy give you thermodynamics properties. So these are the 5 laws that we're going to focus on many times throughout this module. So these are the answer for tutorial question number 4. Okay, quite straightforward. Now try to look at one example by using what we mean just now, and also the step that we're going through. Just a refreshment, just a refresh on that. Now we are having piston cylinder devices that contain 0.9, the dot is missing, 0.9 kilo of oxygen with the initial temperature of 27 Celsius. So for this module, temperature is one of the important parameter. Sometimes you need to convert Celsius to Kelvin, right? So just be careful. And a pressure due to the weight of 150 kilopascal. So you should familiar what is Pascal. Pascal is linked to pressure. And again, in your mind, you should always able to recall what is the equation for pressure. Pressure is force divided by area. It gives you Newton over meter square. So this kind of analysis is in your last chapter. We call it dimensionless analysis. So it's important. So Newton over meter square will equal to Pascal. So this kind of concept you should always remind yourself. All right. Then heat is added to the gas until you reach a temperature of 600 something Celsius, 627. Determine the amount of heat that added during this process. Okay, so you are given a diagram like this, and then there's a Q inside there, and there's a W coming out. So this is just a demonstration what is going to happen throughout this module. So these problems that we're going to demonstrate to you how we're going to apply the 9 steps that we recommend to you just now. And then we're going to use what is ideal gas equation, and also what is the first thermodynamic law for this system. Okay. Now don't worry about the numbers, for example, the value. Try to understand the concept that we try to deliver to you. Right? At least everything makes sense to you. Then you are fine. Because all this information you can extract it after the lecture. Right? From my PowerPoint slides. So what is given? You write the important parameter on your paper. So you pull out the mass, 0.95. You pull out the temperature, 27 degrees C, and then the notation also very important. So the initial, normally we will put T1 or at 0.1 equal to something. Temperature after an effect, T2 will equal to 627 degrees C. And our pressure is constant. Given here is 150 kilopascal. Here. So we need to find what? We need to find amount of heat, which is our Q in the process. So the next question you need to ask yourself is, what does this topic related to? Or this question related to which chapter? So you need to go and find the correct equation. All right. So so I assume you already learned that all the equation, but anyway, I will still go into detail, but this is just a demonstration how we solve question. So first law of equation, first law of thermodynamics will give you this equation. Q minus W equal to energy changes. Q is heat flow. W is a work, W-O-R-K, work done by the system, equal to the change of energy. Right? So thermodynamic always look at Q and W, and also E. So assumption, we have a few assumptions. Your energy will be constant for your internal energy, E equal to U, and then your ideal gas is constant. for example, right? So you can change all this formula to this. So all this will be new to you for today. Don't worry about all this formula. Try to, what we're trying to do here is we're going to demonstrate the step that we will use when we try to solve problems. First, we extract information. Second one, be sure what is going to what the question try to ask you. Then the third step is that or even examiner the marker for your paper will look for equation that you use, right? So it's important to write the equation in your answer, and then assumption. So this one assumption will give you it will help you to solve the question more easily. For example, if your correct assumption, then you're able to call out more information that related to the question. For example, you're able to call the internal energy equal to mu, for example. So don't worry about the detail of all these formula. You'll learn it later on. Okay. Yeah. And then you will try to integrate it in this question. So work done through the boundary layer given by this equation. So bear in mind for this module, you need to polish up your integration skill. All right. Today, if you're still blur about how to do integration, is still fine, but you need to make some times to polish up the integration procedure. If you're not sure how to do, go back to the mathematics textbook and have your own study time. Okay, just some head up for you. Okay, then you call out the ideal gas formula. All right, so at the moment you just accept all the formula, and then you apply it. And for this module, most of the time you refer to a table. For in this case, you refer to a table, you get a certain value, and then you substitute in, you get the answer. Okay. So this is how we solve normally. Don't worry about all these. All these important is that you see or you understand that, oh, lecturer trying to demonstrate the 9 steps that we cover in your tutorial question 1. These are the steps that you're trying to do. So yeah. Okay, we go for a few more definition and then we go for a short break. Okay. Right. We look at a system and a control volume. So in your tutorial question number 6, what is system? System is we look at a quantity of mass in a fixed boundary. So in the diagram that you see on your screen here, so you have a boundary that given by a dashed line here. So all the mass inside here, inside the bound, inside this dash line is called system. Okay, called system. And the control volume is an imagery, means it's not a real volume, but it's a arbitrary volume that you fix inside the system to help you to do analysis. Okay. What else? This is the diagram is called control volume. So we want to analyze a flow inside a pipe, a T-junction here. Then to analyze what is inside the pipe here, we need to define the area of your research or area of your calculation by that dashed line here. We call it control volume. And then the control surface is a surface that touch the line here. So volume, you know what is definition of volume. Surface, you also know surface is a 2D dimension. Volume is a 3D dimension. Okay. And the word control means you have something to focus on. It's your reference boundary. Okay, so these are the terms that we try to clear before we do a more complex equation. Okay, so we clear, we have defined what is system, we define what is the control volume, and then how to find your control surface. Okay, I think we stop here and then we come back for your tutorial question number 8. And let me stop the recording.